Good morning. Today we are going to deal with the topic finance growth and decay. So, under finance, there are key concepts that we have to look at. We have got key concepts that we have to understand. So, whenever you are dealing with finance, whenever you are dealing with business, it, it's either the assets that you acquire will increase in price or will increase in their value. That is to say, they earn interest or they decrease in their value. The assets decrease in their value in any business, meaning to say the assets do depreciate. So basically, these are the concepts, some of the key concepts that we'll be looking at: the concept of interest, the concept of depreciation, and we might also be looking at the concept of exchange rate, because in any business there are moments whereby we have to deal with transactions using different currencies. For example, when you want to buy something in South Africa whilst you are in China, or when you want to buy something in the USA, when you're in China, you realize those two countries use different currencies, and there's need for you to apply to buy one currency so that you'll be able to buy the other items in a different currency. So whenever we'll be solving problems under finance, we are going to deal with a different set of formulas. And the set of formula, we have ones which are on the formula sheet that we use in the exam. This 1, 2, 3, 4, 5, 6. We can get this formula on the formula sheet, and we have got additional formula that are not on the formula sheet, but at some point you are expected to utilize them in the exam room. So for instance, when we are calculating interest, we can calculate interest. Yeah, when we are calculating interest, these are the two different formulas that we have to use. And the first formula, we use it when we are dealing with simple interest. And the second formula, we use it when we are dealing with compound interest. What are the variables on our formula? This A and this A, you have to understand that is the accumulated amount. The accumulated amount, what will be the amount, the total amount that you'll be having after investing your amount. This P is representing what we call the initial investment, or the principal, or the money that you start with. That I, this I is representing the interest rate. The I is representing the interest rate, and the N is actually representing the time to maturity, is referring to the time to maturity. So these two formulae will be used whenever we want to calculate interest, but it's very important that you check whether you are going to use simple interest or you are going to be using compound interest. Sometimes they don't actually bring that use simple interest or use compound interest, but you have to understand that if it's not specified, for instance, when it comes to problems involving inflation, they are not going to tell you which formula to use, but always know that when calculating problems to do with inflation, you have to use the formula for compound interest, this one. So when you are dealing with problems that relate to inflation, for instance, know that we are going to be using this formula. And when you are dealing with formula problems that are involving higher purchase, know that you have to use the formula for simple interest. So always take note there. Then number two, we have this other set of formulae, the second set of formulae there. So on the second set, here we are. Here the formulae. We check they are now having negative here, meaning to say there is loss of value. So we use these methods when you are calculating depreciation. We use these methods when you are calculating depreciation. And the first one, we use it when we are using what we call the straight line method of calculating depreciation. The straight line method of calculating depreciation. Then our second one, it means we'll be using it to calculate depreciation using the reducing balance method, which is sometimes called the diminishing balance method. Diminishing balance method. So the variables in this formula and this formula are the same. This A in these now formulas, you'd realize that the A here and the A here, one, it's representing what we call the scrap value or the residual value or the net book value. This P will be representing the initial cost of the asset, the initial cost of the initial investment. The I here and the I here are now representing the depreciation rate, the rate at which the assets are losing value. Unlike here, we said the I's are interest rate, the rate at which the asset is increasing its value. Then the N is referring to the lifespan of the asset, the lifespan of the assets. So you have to take note of these formulas. And when calculating these, it's not, you have to be able to manipulate this formula, because the question, when they come, they can just require you to calculate any of the variables here as identified in the formula. Then lastly, we have these other two formulas which are also on the formula sheet. Yeah, these ones, we use these when we are dealing with annuities. When we are dealing with annuities, an annuity exists when there is a fixed amount of money which is being paid periodically. For example, if we are to say you are paying 100 Rand per month, it's an annuity. Unlike these ones, we use them when it's a lump sum. These two, we use them when it's a lump sum investment. But these ones, we use them when we are dealing with annuities, when we are dealing with annuities. And you have to take note that annuities come in different forms. It can be repayment of loan using a fixed amount. For example, when you borrow money, then you'll be paying that money back by maybe 5,000 periodically. Those payments becomes an annuity. So you have to take note that when the moment you hear the amounts that are going to be paid periodically, same amounts that are going to be paid periodically, we'll be talking of an annuity. So in other words, we have to know how to calculate the future value of an annuity and how to calculate the present value of an annuity. So this F is the future value of an annuity. This P is the present value of an annuity. Then this X and this X is just representing the monthly payment that you'll be making. If in case you are the one making it, or if you are the one receiving it, that periodic payment, it's not always monthly, it can be quarterly, it can be yearly, but the periodic payment that is being made constantly is what we are calling X. Then our I here is just representing the rate of interest. Then our N is representing the number of payments that are expected. So these are the formulas that you expect to see on the formula sheet. Additional to that, if you check, in this case, we were saying, in addition to that, we will add these other formulas which are not on the formula sheet, but you can be required to use them. For instance, the question can say calculate interest amount. You have to take note, interest amount is different from the interest rate. The interest rate is given as a percentage, interest amount is the actual dollar value. So for you to calculate, or the actual rand value, for you to calculate the interest amount, you have to know that it's accumulated amount minus the principal. So in other words, the accumulated amount on interest, we said it's A, and the principal is P, or the initial investment. So the accumulated amount can be given as, the interest amount can be given as A minus P, where our A and P are taken from the formula for interest. Then you can also be required to calculate the depreciation amount, which is different from the depreciation rate. Rate is a percentage, amount is in the rand value. So if you want to calculate the depreciation amount, it means we want the actual value that was lost. So to get here, depreciation amount, take note here, is supposed to be original cost minus scrap value. Original cost minus scrap value. Not scrap value minus original cost. It's original cost minus scrap value. In other words, based on our formula there, it means we are saying P, because the P is the one which is representing the original cost or the initial investment, minus A, and the A will be the scrap value or the residual value or the book value. Then on top of that, you are supposed to be able to calculate what we call the effective annual rate. The effective annual rate. This is the formula that we use. So the effective annual rate will be equal to 1 plus I nominal, which is nominal rate. Effective annual rate is equal to 1 plus nominal rate. Nominal rate is actually the rate that will be mostly given in question, the rate that accommodates compounds. So it means the rate that accommodates the compounds divided by the number of compounds that you are going to make per annum. Then you raise that to the power, the number of compounds minus 1. So it means you can be given the effective rate, then be expected to calculate maybe the nominal rate or the number of compounds, or you can be given the nominal rate and the number of compounds and be expected to calculate the effective rate. So you are also supposed to be in a position to manipulate any of these formulas that we have listed here. As we'll be tackling more questions, you realize that there might be some other formulas that you need to familiarize yourself with. So let's go to the question. So here is the question. So number 1, there is the question. So the first question is saying there, 6 years ago, Tabo bought a phone for 13,000. So already means it's the original cost. The value of the phone depreciated annually according to the reducing balance method. So we already know that we are going to, it was depreciating using the reducing balance method. The value of the phone is now 8,000. This is the value of the phone. So this is now the book value or the residual value. Then the question is saying calculate the annual rate of depreciation. Calculate the annual rate of depreciation. So after reading, when answering these questions, you are supposed to be in a position to identify which formula are you going to be using, which formula are you going to be using. So from the formulas that we have listed, we need to use the formula for reducing balance method under depreciation. And that formula here is the formula for reducing balance method. Here it is. So go and extract that formula. So we are saying we are going to use this formula. So we need to extract that formula. So it means we are now going to have the formula A equal to P open bracket 1 minus I to the power N. Then you have to identify what you are given. Original cost, we said it's P. Then the book value, we said it's A. So in other words, from what we are given, A is equal to 8, 3, 3, 7.75. Then our B, our P there is the original cost of the phone, which is 13,000. Then the question is saying calculate the annual rate of depreciation, which is denoted by I. And they want the value of the phone is now, and the phone was bought 6 years ago. So our I is missing That's what they want you to calculate, and our n is equal to 6. So substitute the variables. So we are going to get 8337.75 being equal to P, which is 13,000. Then we have 1 minus I. We do not know that I to the power n is 6. So from here we have substituted. So we now want to solve the equation. So it means we are going to divide both sides by 13,000. So we'll come divide here by 13,000. We come divide here by 13,000. So this one and this one are going to divide each other. You are now left with 8,337.75 over 13,000 being equal to 1 minus I to the power 6. So we want to take note of that 6. So it means we are now going to bring the 6th root both sides. So here we will get the 6th root is the 6th root. Here we do also the 6th root. So from there you are left with the 6th root of 8337.75 over 13,000 being equated to 1 minus I. Then we have to make I the subject of the formula. So to make I the subject of the formula, the I there is negative. So it means we take the I to this side, it becomes positive. Then we take this side to here, it becomes negative. So conclusively, we are going to be left with our I being equal to, so there our I is being equal to 1 minus the 6th root of 8337.75 all over 13,000. So punch that on the calculator. So if you punch that on the calculator, we are going to have 1 minus is the 6th root. So it's 8337.75 over 13,000. So we are getting I to be equal to 0.0 7 1 35071335. So it's 7135244538244 538. So that's our I. Then we go back to our question. What is the question saying? Calculate the annual rate of depreciation. At the end, don't forget to answer the question. Therefore, the annual rate of depreciation annual rate of depreciation is equal to, always make sure that the rate is given as a percentage. So to get the percentage, you multiply this answer that you get by 100. And once you multiply this by 100, what it simply means is you are going to move to the right two places. So our final answer becomes, if we move here, 1, 2. So it means our final answer is now going to be 7 comma 7 comma 1. If you check 4, so it's giving us 7,14%. Then we go to the next question. Let's go to the next question. Which is the second question. So here is the second question. They are saying Eric and Tandy need to save 80,000 each to go for a holiday at the end of December 2027. Then Tandy decides that she will start saving at the end of January 2025. She will make 36 monthly deposits into a savings account that pays interest at 8.6% per annum, compounded monthly. The deposits will be made at the end of each month. Eric calculates that if he makes 40 deposits of 1,402.31 starting at the end of January 24, he will have enough money to go on holiday. He will make these deposits into a savings account at the end of each month. The savings account pays interest at 8.6% per annum compounded monthly. The question is saying calculate the difference between the total amount that Eric and Tandy will deposit into their respective perfect into their respective savings account over the given period. So it means we have to calculate the total amounts that they are going to deposit each. So for us to calculate for Eric, it's easy. We can calculate Eric's total deposit. Eric's total deposit. So it will be the monthly deposit that is going to be making, which we are told here is going to be 1,402. So it's going to be 1,402.31 multiplied by the months he is going to deposit, and we are told Eric will deposit for 48 months. So the total that Eric will deposit is this one. So if we go to our calculator, what are we going to get? So we go, so it means we are going to have 1,402.31 multiplied by 48. So the answer is 67,310. The answer that we are going to get is 67,310.88. So we have that. That's the total for Eric. Is 67,310.88. Then we go to the next person. The next person is Tandy. But for Tandy, we do not even know the monthly deposit. So we first have to calculate the monthly deposit. But from the information that we are given, 8 is the amount that they want when in December, at the end of December 2027. So it means this 8 is the future value. But to raise this money, what is this person going to do? He decides to deposit 36 monthly deposits into a savings account, meaning to say, because they are continuous deposits, meaning to say this becomes an annuity. So we are going to use the future value of an annuity. So the formula is going to be, let's go to our formula sheet, to the formulas that we are going to use. So here are the formulas, but the one for future value of an annuity, here it is. So we are going to use that. This is the formula that we are going to use. So that we calculate how much is the person going to be paying per month, how much is the person going to be depositing per month. So we go check how much is he going to be depositing per month. So we have that. So let's copy the formula equal to, that formula is having X, which is the monthly deposit, then bigger bracket, smaller bracket, we are going to have 1 plus I to the power n minus 1 all over I. Then we check what's the future value is 80,000. So our future value there, we are seeing it is equal to 80,000. Then what's the X? X is representing the monthly deposit. We don't know what Tandy is going to be depositing per month. So it therefore means that the X is missing. What is our I there? Our I, you are told that it's 8.6, but that rate, convert it to a decimal. So when you divide it by 100, it means this rate converts to 0.086. So it means our rate is going to be 0.086. But you are told that it's being compounded monthly. So this is going to be divided by 12. Because per annum we are going to compound it 12 months. And then the N, you are told, is going to do the payments in 46, 48. Sorry, 36. Here it is. They said 36. So 36. So let us calculate the monthly deposit. So it means we are going to have 80,000 being equated to X, which we do not know. Then we have a bracket there. Which is going to be 1 plus our I is 0.086 divided by 12. Yeah, it must be a bit bigger. To the power n, where our n is 36 minus 1 all over I, which is 0.086 all over 12. Now to solve, because we want to solve for x, it means we go both sides. We are going to multiply here by the denominator is 0.086 over 12 divided by the numerator. The numerator is 1 plus 0.086 over 12 to the power 36 minus 1. So what we do on the right-hand side, we do it on the left-hand side. So here it means this value is also going to be multiplied by 0.086 over 12 divided by, so it's going to be 1 plus 0.086 all over 12 to the power 36 minus 1. So if we check on the right hand side, this big bracket will cancel with this big bracket. Then this will cancel, will divide by that. So we are left with x. So conclusively, it therefore means that our x will be equal to, punch that on the calculator. Oh, it means we are now going to have fraction. So we are going to have 0.086 over 12 multiplied by 80,000 divided by, okay, we can just write the same way. It's put there 1 plus 0.086 divided by 12. Then we close the bracket. That one is raised to the power 36 minus 1. We are getting 1955.7778.239. So we are getting 1955.778239. And if you round that value to 2 decimal places, so let us write the whole of it. Let us write the whole of it. So we got 1955.778239. But we are dealing with money, it must be to 2 decimal places. So it means this will be equal to 1955.78. So if we now want to calculate the total, because we need the total than this total deposit. So it means here, therefore, than this total deposit will be equal to that amount there. Let's put it here. That amount there, which is 1955.78 multiplied by the months which were paid, which is 36. So simplifying that, we go to our calculator. So it will mean this will be equal to simplify that. So we are going to have 1955.78 times 36. That is going to give us a 7408 0.08. Seventy 408.08. Then check the question. The question does not want the totals. The question wants actually the difference between the totals. So to get the difference between those totals, so we now answer the question. The question wants the difference between those totals. So what is going to happen to get those differences? The ends difference between their totals between their total deposits is now being equal to 70, which is here, 408.08 minus the total for Eric, which is 67, 310.88. So the final answer is now equal to, we go to our calculator, So it's that minus 67,310.88, which is giving us 397.20. 397.20. And kindly take note here on our calculator. Kindly take note the answer that we got on our calculator is 3097.2, but we are dealing with money. Always make sure that you leave your final answer to 2 decimal places because we are dealing with money. Then we go to the next question. So having done this, let's remove it. Let's go to the next question. So we are still going. So it's saying Esbana was granted a loan of 225,000. The rate of interest for the loan is 9% per annum, compounded monthly. The Esbana will make monthly payments of 5,000 starting exactly 4 months after the loan was granted. How many payments will Esbana make to settle the loan? So we want to determine the number of payments that are going to be made. But after reading this, we have to identify the correct formula that we have to use. So from the formulas that you are given, if you check from what we are given, this person is granted a loan and the loan is granted now. Here it is. So this is the present value. But if you check, it's going to be to make monthly payments to pay the loan. So it means whenever you are talking of repayment of loan, we use the formula for present value of an annuity. So if we are to check using the formula for present value of an annuity, it therefore means we are going to use this formula. Here is the formula that we are going to be using. Present value of an annuity. Here it is. So it's going to be here the formula we are going to use. It's saying P is equal to X. Then we put big bracket. We have 1 minus then we have a small bracket. We have our 1 plus I to the power a negative N or over I. Copy the correct formula. Then we want to identify the variables. So we are having P, we are having X, we are having I, we are having N. So the question is asking how many payments. So then how many payments will Lesbana make to settle the loan? So number 1, we are going to have this, and this is what is missing. Then I, you are told it's 9%, but you convert that to a decimal by dividing it by 100. So it becomes 0.09, but you are told it's compounded monthly. So we are going to divide that rate by 12 X is representing the monthly payments, which is 5,500. Then we have to take note of the P. What's our P there? If you check, the amount which was borrowed is 225, but there's something that happened there. If you check, this person, you are told that starting payment exactly 4 months after, meaning to say, yeah, we are start taking that from here, meaning to say this man was generating interest for the bank for 3 months before he started paying in the fourth month. So you have to adjust this using this formula. Yeah, you have to adjust that amount using the formula. Here is the formula. So it means the P that we want here is going to be extracted from the formula. The P that we want here, take note, the P that we want here is going to be extracted from the formula A equal to P, open bracket, 1 plus I to the power N. And take note, this P and this P are not the same. The P that we are going to put here is this value of A here that we are going to get. So it means this P is going to be the value of the loan, which was 225,000 adjusted for the 3 months. So it's gonna be 1 plus I. Our I is 0.09 divided by 12 raised to the power 3, which is the 3 months. So having this, we can now come and substitute in the formula there. So let's substitute in the formula. So it means we are going to have our P, which is 225 adjust 1 plus 0.09 divided by 12. Then this is now being raised to the power 3. That must be equal to X there, which is 5.5. Then we are having 1 minus, we're having 1 minus I, which is 0.1 minus, then we have 1 plus, the rate is 0.09 over 12 to the power negative n. Here is O over I, but our I is 0.09 O over 12. So to simplify, to leave this part in bigger bracket alone, it means we have to multiply both sides. So we are going to multiply here by this denominator, 0.09 over 12 divided by that numerator, which is 5,000. Here, the same applies. Over, sorry, it's 5,500, not 5,000. Yeah, it's 5,500. Here it's 5,500. So it means this will divide with that, that will divide with that. So when you simplify on the left-hand side, there you'll be left with, okay, in other way, we can punch that on the calculator. What is it that we are left with? Here, it's going to be equal to the left-hand side. It's gonna be 1 minus 1 plus 0.09 over 12 to the power n negative n. So the other side, yeah, we are going to use our calculator. So we are going to have 0.09 over 12 being equated, it's over 5.5 multiplied by 225,000, which has been adjusted for 3 months, which is 1 plus 0.09 over 12. Then it's to the power 3. So here we are getting 0.3137734,959. So that is what we are going to get on our left-hand side. So it's 0.31, 0.31, 377, 377, 34959, 4959. So this is what we are having, and from there we now want to make that n subject of the formula. So we take this bracket, which is negative, to that side, and we take this side to this side. So it means when this one comes to this side, it becomes positive, and when this one becomes to this side, it becomes 1 minus that. So it means we are now going to be left with 1 plus 0.09 over 12 to the power n negative n, because when it comes here, it becomes positive, being equal to 1 minus that. So we go to our calculator. So it's going to be what our 1 minus answer. We got 0.6862 there. So it's 0.686226 5041. This is what we are now having. So when we are solving here, so it means we are now going to have our negative n. We introduce logarithm. So our negative n will be equal to a log with our base as this base, which is 1 plus 0.09 over 12. Why did we substitute this as it is without simplifying? Because we are trying to avoid to take a rounded off value there, since we already have another one which is rounded. So we do not want to distort our answer. 68622654041. So it means we need to go to our calculator and punch that answer. So it's going to be equal to, what's happening now? Okay. So when we simplify that, let's go to our calculator. So it means we are going to have shift log. Oh, what's happening? Sorry, no need for shift. Just take log our base there. It's going to be 1 plus 0.09 divided by 12. That's our base there. Then what are we going to have there? This is what we are getting, minus 50 point. So it means our negative n here is equal to minus 50.394375 4375. Let's go back and check properly. Three nine four three. So it's 39437595795. That's the value. So dividing both sides by a negative, and let's just round it to 2 decimal places. So it means we are going to have our n being equated to 50.39 payments. But if you check payments, we cannot have a fraction of a payment. Yes, the amount can be less, but the payment, whether it's a part payment, we have to know that payment are examples of discrete values. So it means that you will make 51 payments. You don't round off, you just take the next whole number. So it means 51 payments will be made. We have to take note of what the question was saying. We have to take note of what the question was saying. In this case, if you check, the question strictly asks, how many payments will Lesbana make to settle the loan? So it means the payments will be 51 payments. 50 payments are of 5,500, and the last payment, the want to make them 51, will be less than 5.5. But if the question was asking how many payments of 5,500 Oh, let's banner make. It means we are having 50 payments of 5,500. Why? Because the last payment will be less than that. But in this case, the question just asks how many payments without specifying the size of the payment. So it means the answer is going to be 51 payments will be made. Bearing in mind that the last payment will be less than 5,500 because it's a fraction, which is 0.39. Right. Then, thank you very much. Make sure that you stay focused so that we attain our objective. I wish you the best. Always maintain resilience and balance. Thank you very much. Keep pushing.